Okay, here in example 9, particle is initially at the origin. So this is talking about its place displacement. Moving to the right at 5 centimeters per second. So that's talking about velocity. And it accelerates with time. Now we're talking about acceleration by this formula. Acceleration equals 4 subtract 2t. All right, if we think back to how kinematics works, and we have s of t, v of t, a of t, and when we looked at differentiation, we knew that the exponents decrease each time. We have an acceleration function that's linear, and we integrate it. We should end up with a quadratic function for velocity, and we should end up with a cubic function for displacement. Okay, so just keeping our mind straight about that kind of concept. So answer the following without a calculator. Find the velocity function of the particle. Sketch its graph from 0 to 6. Okay, so velocity function, we're looking for this, and we're given this linear acceleration function. So we know we should end up with a quadratic. So part A, velocity function is equal to the integral of the acceleration function. That acceleration function is 4 subtract 2t. So 4t subtract 2, t squared over 2. Whoops. It's not a definite integral, so I do not use that notation, plus c. 4t subtract t squared plus c. Okay, we need to sketch this graph now. But we need to calculate what the c value is so that we know how to sketch it. So this is v of t. So keeping in mind, and this is t. So this is velocity function. In our information, it says a particle is initially at the origin. So that's displacement. So that's not on this graph, and moving to the right at 5 centimeters per second. So originally, when time is 0, the velocity is 5. So we know that we have this point on our graph, 0, 5. So we can substitute this in. And see that c equals 5. Therefore, the function is actually minus t squared plus 4t plus 5. Okay, so to help us with the rest of this graph, let's figure out what the zeros are. And the zeros are -1 and 5. So that means that at -1 we would cross the x-axis, but that would be negative time, so that won't be included on our graph. And over here at 5, we will also cross the x-axis. So what we know about quadratics then is that the maximum or minimum is halfway in between these zeros. So that's 6, so that would occur at 2. That means that here's our maximum somewhere up here like this. And we need to take this as far as 6. If we substitute 6 into this function to get the exact value there, -36 plus 24 plus 5, which is -7. So this would be -7 down here. All right, there's our sketch. Okay, B, for the first 6 seconds of motion, so from 0 to 6, determine the displacement of the particle. So displacement just means the end point, subtract the beginning point from our displacement. So far we have the velocity function here. We need to calculate the displacement function now. So b, the displacement function, will be the integral of the velocity function. And the velocity function we determined was negative t squared plus 4t plus 5. Integrate that. So negative t cubed over 3, 4t squared over 2, 5t plus c. And simplifying looks like this. Now remember, in our original information, so a lot was said up here, even though it's just a little question. A lot was said. A particle is initially at the origin. So now we've got the displacement function. It's initially at the origin. That means that we have this point on our graph, our displacement graph, 0, 0. We can substitute that in to calculate c, and we can see that c would be 0. Therefore, the displacement graph is plus 5t. Negative t cubed over 3 plus 2t squared plus 5t. Okay, now to determine the displacement. S of 6 subtract S of 0. So S of 6 is negative 6 cubed over 3 plus 2 times 6 squared plus 5 times 6. Subtract 0 in there, that will just equal 0. And 6 cubed is 216 over 3, which actually is 72. Let's put 72 plus, oh, that's a negative 72, plus 72, plus 30. So 30, and our units is, from our question, we were going centimeters per second, so our units is centimeters. Okay, that's B. For the first, that's the first part of B. Second part of B is the total distance traveled. Okay, here we go. We need to do these 5 steps. So second part of B, 5 steps. Step 1, draw the velocity sign diagram. Velocity function is negative t squared plus 4t plus 5. And we already figured out the zeros up here. They are negative 1 and 5. So the only one that truly applies is 5, because we can't have a negative time. 5. And from our actual graph, we can see that it's above the x-axis and then below the x-axis, so positive and then negative. Step 2 is calculate S of t by integration. Well, we've already done that as well. So S of t is negative t cubed over 3 plus 2t squared plus 5t. The next step is determine S of t1, S of t2, and any S of t whenever we change directions. So S of t1 is 0, so that's going to be 0. We're looking from 0 to 6. Okay, so S of 6, we already determined that up here, excuse me, is 30 centimeters. And anytime it changes directions, which is just S of 5, so we need to calculate that. So negative 125 over 3 plus 50 plus 25 Negative 125 over 3 plus 75 times 3 is 225. So 100 over 3, or 33 1/3 centimeters. All right, next step, draw a motion diagram. So motion diagram, we need to include all these places on here. So motion diagram, we start at 0. We've got 30, and we've got 33 1/3. And this occurs at 0 times, so that's our first place. This occurs at 5, so we go directly to there, and then this occurs at 6. Okay. So this is our first leg of the journey, 33 1/3. Second leg of the journey is 3 1/3. So the total is 36 2/3 centimeters. Whew. A lot of work that is. Okay, have we answered the full question? Find the displacement, total distance traveled, yes. Okay, just as a reminder, let's look at this on the graphing calculator. And we can check the total distance traveled by using our calculator, this integral sign. And we're going from 0 to 6. We're looking at we're finding total distance traveled, so we're looking at the velocity function, which was negative t squared plus 4t plus 5, and with respect to t. And we got 30. Okay, so the reason we didn't get the correct answer, again, make sure we have those absolute value symbols in there. So let's do this again. Here we need our absolute value symbol, which we get from here. And now we can do that. Let's see what the difference is. Oops. Negative t squared (36 and 6 repeating), so 36 2/3. Okay, so absolute value on our calculator, whether it's changing direction or not, calculates the total distance. Your homework from this section, part 19C.1 and 19C.2. Okay, so look in your homework document to find those questions. Have fun.